So let's see the part 1. Organic chemistry, organic chemistry. Some basic principle and technique. Some basic principles and technique. Right. So let's see the first question. So tertiary butyl carbocation is more stable. So compound name is given tertiary butyl carbocation is more stable than more stable than secondary butyl carbocation because of the following. So it is asked in 2020. So let's see. So due to the hyperconjugations, first I will make the structure of that compound. So it will be tertiary butyl carbocation, right? So this is carbocations means carbon will be carrying positive charge, and tertiary, so it is connected with 3R. So this will be the tertiary butyl carbocation. So butyl means how many carbons? 1 for meth, right? One carbon is meth, eth, prop, but. So 4 carbons are there. So this plus is connected. So it can be written as like this also. So this plus is connected with this 3 methyl group of carbon, right? So this is your tertiary butyl carbocation. So it is more stable than secondary carbocation. So secondary means this carbon will be connected with 2 methyl group and 1 H. So this is your 2-degree carbocation. This is your 3-degree carbocation. So in 3-degree carbocation, more hydrogen is there. So due to the more hyperconjugation, right? Because this carbocation is lack of electron. If it wants electron, then it will be given by this methyl group, this methyl group, this methyl group. So are there more methyl group is there, so there will be less electron deficient on this carbocation. So that will be that make it more stable. Then it will be the more stable. Understood? So more the number of alpha hydrogen, more will be the hyperconjugation effect. Hence, more will be the stability of the carbocation. Hence, 3-degree carbocation is more stable than 2-degree. So please write this explanation. Now see the question number 2. A liquid compound X. So its state is liquid. Liquid compound can be purified by steam distillation. So how it is purified? Purified by steam distillation. So compound should be steam volatile and immiscible with water, right? So it should be immiscible, right? So it should be immiscible with water, right? Aniline can be prepared from aniline water mixture by applying this method. So aniline means benzene with the functional group NH2 is there. So this compound is called aniline. So it is separated from the alanine water combination. ठीक है, प्लीज राइट इट डाउन देन. Now see the question number third. How many sp2 hybridized carbon atom is there? Carbon atom. And second is you have to find the pi bond present in the following compound. So the compound is given. So its structure is like this. So it is benzene with alternate pi bond, right? With this C triple bond C carbon is attached with C double bond O CH3. Like this. It is asked in 2020. So for this, I will give you the some concept first. So see, when carbon making single bond, right, then it is sp3 hybridized. When carbon is making double bond, then it is sp2 hybridized. And when it is making triple bond, it is forming sp hybridization. So please remember this shortcut, right? So I will make this a structure in now expand form. For expand, so this is representing carbon corner, right? And each carbon is attached with one hydrogen to complete its octet, right? As we know, carbon makes 4 bonds. So you can count here bonds. 1, 2, 3, 4, right? So you can see here, this carbon is making double bond with another. So it will be sp2 hybridized. Again, this is making double bond. So it is also sp2 hybridized. This is also, so it is sp2. This is also sp2. Right. So you can see here sp2 now. So this is also making 4 bond and double bond is there. So it is also sp2. Here sp2. So how many sp2 are there? Total here 6. You can count. 1, 2, 3, 4, 5, 6. So total 6 sp2 hybridization is there in the benzene itself. Now it is triple bond. So it will be what? It will be sp only, right? It is also sp hybridization. That double bond is there here. So it will be sp2, right? So you have to count the sp2 hybridization only. So now add 1, right? So it will be total 7, right? 7 sp2 hybridization is there, right? And last one will be forming sp3 hybridization because all single bonds are there. Now we have to count the pi bonds, right? So you can count the pi bonds with, so 1 pi bond, this is 2, this is 3, this is 4, this is 5, this is 6. 4, this is 5, this is 6. So total 6 pi bonds are there, 6 pi bonds. Understood? So for pi bond, there is trick. If single bond is there, no pi bond is there. No pi bond. If double bond is there, 1 pi, another will be sigma. And if triple bond is there, one is sigma and rest of the 2 will be the pi bonds. So this will be the 2 pi and 1 sigma. Here 1 sigma, 1 pi. Here 0 pi plus 1 sigma. Understood? So please write it down now. Now see the question number 4. So number of sigma and pi bond. So this symbol is called sigma and this symbol is called pi bond. So in the compound pent 2 in 4 ion. So compound name is given pent 2 in 4 ion. Right. It means on second carbon double bond is there. and on fourth carbon triple bond is there. Ion means triple bond and in means double bond is there. Understood? So I will make the diagram first. It is asked in 2019. So see. So it will be how many carbon? Pent means four carbons. So 1, 2, 3, 4. Suppose I am counting started from here. So it is 1, 2, 3, 4. So second carbon will contain double bond and fourth will contain what? Triple bond is there, right? So pent. It is pent now. So 1, 2, 1, 2, 3, 4, 5. But means 4, right? Pent means 5 carbon are there. So one carbon is add, please add one more carbon. So this will contain the third triple bond, right? And rest will be the hydrogen. So attach hydrogen also. 1, 2, 3 bonds. So one hydrogen will be there. Here one. No bond, no more bond is there because it is already containing 4 bond, right? So this is 1, 2, 3, 4. So 4 bond is there. So it will make one more hydrogen bond. Right. So now count sigma and pi bonds. So I will use different color, suppose. So this is your sigma, sigma. Single bond is sigma, right? Sigma. This is sigma, this is pi. This is sigma, sigma, pi, pi, sigma, sigma. So now total sigma bond is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total is sigma is 10. So pi bond now count. It is 1, 2, 3. Only 3 pi bond is there. So please write it down. So for counting the sigma and pi bond, you have to draw the structure. This is given the chemical name, right? IUPAC name is given, right? But you have to draw the structure for counting the sigma and pi bond. So please mind the steps.